All right, gang, as promised, next up, logarithmic functions. But before we get into logarithmic functions, I want to step back a little bit and revisit exponential functions uh, and build on what we did in the previous video. Now, gang, so far, we have looked at the simplest form of an exponential function. Uh, and it turns out that probably a more common form of this that we run into in this course is something that looks like this: f of x equal a times b raised to the x power, where a is sort of thought of in this sense kind of as a leading coefficient. Don't let that stress you out if that makes no sense. And b is still your base. So the types of things that we run into would be to calculate an ending balance after t years of $5,000 when compounded annually at 5% over t years. So you can see that there's going to be a number out here that represents the A. There's going to be a base here that represents the B. So because of the nature of this class, it's this form that should draw most of our attention and make our face hurt with, it's probably not smiles, okay? Okay, guys, having said that, regardless of which we have, there are essentially three bases that interest us. Well, I don't know about interest, but three bases that we want to be able to examine separately, okay? So the three bases, I want you to think about exponential functions in terms of three bases. Base 10, base E, and anything else. This, when we move into logarithms, is going to be log base 10, log base E, log base something else. Now, 10 is probably fine. Anything else is probably fine. 7, 2/3, 8, blah, But, what's up with this E? Well, guys, this E is just kind of like a pi 2 point, I'm sorry, 3 point, I got distracted by my phone, 3.14. But E is, and this is where the 2 comes from, E is a number just like that. It's 2.718281828, and that's as far as I remember. I just remember 8888212. Okay, or 1212 8. That's the way I remember that. But guys, when we get into something called natural logarithms, we're going to talk about base E. So, considering the nature of this course, what I want you to know is that when we talk about base E, we're talking about what's called a natural logarithm, and the base is this irrational number 2.718281828. And I don't know, but anyway, this goes on and on and on forever with no patterns. Now, or I assume no patterns. I don't think anyone has ever found patterns. Now, kind of a side goal. Find the exponential function in the form y equals a times bx that contains the points doing a little bit of mental arithmetic here, 1/6 and 2/12. Okay? Now, guys, this is a little tougher problem, and it's one of those problems that really takes you kind of, getting away from the kids and getting away from the distractions. And trust me, I got 2 kids. I know how the distractions can be with kids. So first of all, let's take a look at this and see what happens. So if I go up to 5, 10, 15, and I'm going to break up the axis here and go from 1 to 2. So we see we've got one point that is a 1/6, and we've got another point at 2/12. And what we're looking for is we're looking for the exponential function that goes through those 2 points. Now, here's the way I want you to get in practice of solving these, okay? First thing I want to do is for y equals a times bx, I want to create the relationship with these points. So when I have 1,6, this tells me that when y is equal to 6, if I take a times b raised to the 1 power, I get this relationship. The 2/12 says that when y is equal to 12, that a times b raised to the 2nd power is equal to 12. Put the largest y on top. So I want 12 equals a times b raised to the 2nd power. I want the 6, which is the smallest, a times b raised to the 1st power. Now I'm going to turn these into fractions and turn my left side into my right side. Can I do that? Absolutely. If 2 things are equal, I can multiply the sides, add the sides, or divide the sides as long as one of the sides isn't equal to 0. Can't divide by 0. So as long as a times b is not equal to 0, I can do this. Now what this allows me to do, it allows me to cancel my a's. I have 12 divided by 6 is 2, and I have b squared over b to the 1st. Now guys, you might have to go back to your properties of exponents, but b squared divided by b to the 1st, we subtract the exponents, so I get b to the 1st power. As this tells me b must be equal to 2. Now, second thing, choose one of these. I'm just going to choose the top one. So I know that 6 must be equal to a times b must be equal to 2 raised to the 1st power. So this clearly comes to 6 equals 2a. Divide both sides by 2. As I know that a must be equal to 3. Putting this and this together, I know that my function has to be y equals a times b raised to the x power. Now, when I graph this, I want to clear out both of these. I have 3 times 2 raised to the x power. And I want to examine this for the points that I have, which are 1 and 2. So I'm just going to run this from 0 to 3. Again, this doesn't matter because I'm going to reset it for my function by going zoom, fit, and I create my exponential function. Come in, let's see if it indeed does go through the points that we have. What's the value when x is equal to 1? Well, it better be 6. And what's the value when x is equal to 2? Well, it better be 12. And it is. So we see our y values right here. Okay? Now, what does this allow us to do? It allows us to set a foundation for working tougher problems. Let's say that we have an investment that after 5 years our investment is $22,768. Hey guys, this is going to be a lot harder, okay, because it's not going to work out nicely like the other one. After 12 years, our investment was $30,645. We can assume compounded interest. So we know that our ending balance is going to be found by taking P, and let's keep it simple, annual interest right now. So N is 1. So P is going to be 1 plus our rate raised to the t power. We can think of this as y equals a times b raised to the x. So this b is going to be found, it's going to be 1 point something, and that will be our rate, whatever, and that'll develop here in just a second. A will be the initial balance. Okay? Now, what rate did we get? And what was our beginning principal? Well, relationship number 1 says that we have an ordered pair 5. And we have 12,645. The first relationship tells me that when y equals a times b to the 5th power, and when y to the 12th power. Now, Darbro said, when I have something like this, what should I do? Let me get this where I should put the biggest number on top. Smallest number on the bottom. And work our magic. All right, so 30,645 divided by 22,768. And guys, I need to go out quite a bit here. I'm going to go out about 5 numbers. Okay. Equals, these cancel. Again, what I tried to teach you in an earlier video was to divide common bases. We take 12 minus 5, and we get b to the 7th. Now, here's a trick. What we're going to do now is we're going to exponentiate both sides to the inverse of, or at least the reciprocal of, the exponent. Now, guys, aside here, there is a property of exponents that says if we have a to the mth raised to the nth power, then this is just a to the m times n. So an example of that, if we have b to the 4th power raised to the 3rd power, this is just b to the 12th. Well, what I want to create here is I want to create b to the 1st. So if I know I multiply these two things, what do I need to multiply 7 by to get b to the 1st power? Well, 1 over 7, because 7 times 1 over 7 is just 1. But guys, if I do that to one side, I have to do it to the other. So guys, after all the smoke clears, I have b equal 1.34597 raised to the 1/7 power. But guys, what I can do there is I've got this answer right here. All I've got to do is just hit power and put 1 divided by 7 in parentheses, and I get b is 1.0434. So that's got to be my base. Now, what did I do before when I had an easy problem? I chose one of my relationships to put my b back in. So I'm just going to go up here and choose my first relationship. And I know that this is I just solved for it, 1.0434 raised to the x, which was 5. Now, can I use my calculator to solve for a? Well, absolutely. That number right there, I need to raise to the 5th power. And then I need to divide both sides by that number. And your calculator allows you to do this very, very cleverly by this command right here, the answer. It's blue, so I have to hit that key first. So what that's going to do is it's going to take 22,768 and it's going to bring the 1.26 or 23642 down here, and it's going to divide by that right here. So I get 18414.38. And I know that my b is 1.0434. So what do I know? I know now that my function, which is a times b raised to the x power, is y equals a times b raised to the x power. But since I'm talking about money, I can put this as a to the t power is 18414.38 times 1 plus 0.0434 raised to the t. This tells me, and what I'll tell you before we figure it out what it tells us, let's see if it works. So I go to y and I go 18414.38 times 1.0434 raised to the x power. Now let's think about our window. What do we want to do? Well, our problem we started out with dealt with 5 years and 12 years. So let's just run this thing from 0 to 15 years. Now, that number's smaller than that one, so we go zoom, fit, and we get our investment. Now, what should be the value? Again, let's go back to what we got here, okay? These are the values we started out with. 5 years after we invested, the money is worth $22,768. So let's go to calc, value, 5. Not bad. It's off a little bit. But you got to remember, we rounded this. We rounded this to 2 places, this to 4 places. Still not bad. It's pretty close, considering we're rounding. Next one, we want to see, well, what's the value after 12 years? Should be close to $30,645. And it's not bad. Now, if that's too far off for you, add more digits. Take this 0.38, take it out to about 5, 6 places. Take this 0.0434 out to 5 or 6 places. This is going to get closer and closer and closer the further digits that we go out. But guys, what I want you guys to see, among other things, is I want you to see that this represents what? Well, that was our P. This is our beginning balance. What's this represent? Well, this is our rate. So this person, to create these amounts of money at 5 years and 12 years after their initial investment, they had to invest $18,414.38 at 4.34% compounded annually to create those two values, okay? Now, if that's just a little bit too much for you, I think there's another way that we can come up with this on our calculator that's really kind of super cool. Let's go back to stat, edit like we did before, and let's clear out some things. And let's clear these things out too. So clear down. And let's put in 5 and 12. 22,768 and 30,645. Now let's go second function quit just like we did before. Let's go to stat. Let's go over to calc. And guys, this time I want you to come all the way down and find exponential regression. Right there, EXPREG. Guys, we put our numbers in L1 and L2. And you can see those are the values we get. Same thing we got before. So if all that dividing by and all that stuff that I just did is just too much for your brain, It's too much for your patience. It's too much for your focus level. It's just too much for whatever it may be. Your handy dandy calculator that you paid all your life earnings to buy does these problems for you. So A again is the beginning balance. The 1.04, this B is 1 plus the right hand side, and that tells you your interest rate. Okay, I got into a little bit more here than I planned to do, so because of that, I'm going to end this video, and we'll start up logarithmic functions after this. So, see ya.